So in this video I am going to discuss with you the working of this merge sort with the help of an example, and we are going to write down a piece of code for this sorting technique. Okay, so this sorting techniques also works on divide and conquer technique as in quick sort technique. Fine. Now what is that technique? In this case the complete array, or you can say the complete list, is divided into sublist. Fine. Or you can say the complete list is divided into n sublist, and each sublist is having one element. Or you can say we'll keep on dividing the list into sublist until we get the sublist having one element only. Fine. After that we are going to merge the sublist, and we will keep on merging the sublist, fine, two adjacent sublist you can say, to produce a new sorted sublist, and we'll keep on merging the sublist until we get one complete sublist, and that sublist would be sorted sublist. So the first step is dividing the given list into sublist. Fine. Second step is merging of those sublist to get a one complete sorted sublist, one complete sorted list. So these are two steps, main steps. See, let us take one example and see how this merge sort will work. So let us take this example. We are having this array name is A. We are having 9 elements, and these are the elements. We are going to sort these elements in ascending order, applying this merge sort. So first step is we are going to divide this list or this array into two equal subarrays. Fine. Equal subarrays means you have to find out the mid position, and you are going to divide this array from that mid position. Fine. See how to find out mid position. 0 plus 8. See, 0 is lower bound, this one is your upper bound. 0 plus 8 is 8. 8 divided by 2, that is 4. So till 4, 0 to 4, one sublist is there. Like this you can write. We are going to divide it into two sublists: 15, 5, 24, 8 and 1. 0, 1, 2, 3, 4. From 0 to 4 we are having one sublist, and from 5 to 8 we are having another sublist: 5, 6, 7, 8, like this. Okay. Still this sublist is having how many elements? 5 elements, but we are going to divide the sublist till we get a sublist having one element. So we are further going to divide this sublist, okay, into two halves. 0 plus 4, that is 4. 4 divided by 2, that is 2. So mid position is 2. From 0 to 2, 15, 5 and 24. This is one sublist, and another sublist would be 8 and 1. From 0, 1, 2, here we have 3 to 4. Right? This will be again divided into two parts, and 3, 16 would be in one subarray, and this 10 and 20 would be in another subarray. Fine. Again this list would be divided into two parts. Middle is 1. 0 plus 2 is 2. 2 divided by 2, that is 1. So 15 and 5, this would be in one list, and this 24 would be in another list. Same, this would be divided into two halves. Fine. And this would be 8, and this would be one sublist would be having one element. This would also be divided into two halves. One is having one element 3, one is having one element 16. Here one is having element 10 and one is having element 20. Now this one is having element 15, another is having element 5. Fine. Now we cannot further divide these sublists. Why so? Because each sublist is having only one element, and that is the condition. You have to stop dividing. You will keep on dividing the sublist until each sublist is having only one element. Now each sublist is having only one element. Now second step was you have to merge these sublists. So now till now this divide, the first step is over. Now second step is what? For merging. Okay. Now if I write down the algorithm, then how you will write? See, merge sort, we are going to take a function merge sort. A is array, we are going to pass lower bound and upper bound. This is lower bound and this one is upper bound, right? And if lower bound is less than upper bound, it means at least that array is having 2 elements. Lower bound is less than upper bound. If 2 elements are there, then you are going to divide that particular list into sublist. Okay, and then each sublist is having only 1 element. So now if this condition is true, now next is we are going to divide the array into 2 halves, equal halves. So for that thing you have to calculate mid element. How to calculate mid element? Mid is equal to lower bound plus upper bound divided by 2. Fine. Now we are again going to recursively call merge sort on array A, and from lower bound to mid. See, from lower bound 0 to mid. Here mid is what? 4, because 0 plus 8 divided by 2, that is 4. So mid is equal to 4. So one half is from 0 to mid, and next half is from 5 to 8, that is mid plus 1 to upper bound. So next is merge sort on array A from mid plus 1 to upper bound, right? And this is what? Recursive call. We are going to recursively, now again we are going to divide this into 2 halves, from 0 to mid plus 1 to this one. Again we are going to divide into 2 halves. So this is a recursive call to left part and to right part. Fine. Finally, after that we are going to merge these arrays. Fine. So after this merge sort, next is what? A method, that is merge. We are going to merge these arrays. Now in merge we are going to pass, in array A we are going to merge these 2 halves. So from lower bound to mid, one half is from lower bound to mid, and another is from mid plus 1 to upper bound. So from mid plus 1 to upper bound. So you are just going to pass these parameters, lower bound, mid and upper bound. Fine. So this is the merge sort. Now here the main thing is you have to write down the code for this merge function. This backbone of this merge sort is this merge function. How we are going to merge these arrays. Okay. Now if you are, this is the recursive call. Fine. This is recursive call. If you draw a recursion tree for this numerical, then how you will draw? See, first of all we are going to call merge sort. Suppose I am going to write ms only. Fine. Array A, I am not going to pass array, I am going to pass this lower bound and upper bound. Lower bound is 0, upper bound is 8. Fine. Lower bound is less than upper bound. Yes, that is true. Then we calculate mid. Mid is equal to 0 plus 8 divided by 2, that is 4. Fine. Again merge, 3 statements are there, this and this. So I am going to divide this into 3 parts. So here we have again merge sort. I'm going to write ms for merge sort. Lower bound to mid. Lower bound is 0, mid is 4. Fine. Again second is merge sort mid plus 1, that is 5 to upper bound is 8. And next is this merge would be lower bound is 0, mid is 4 and upper bound is 8. From 0 to 4 and 5 to 8 we are going to merge these arrays, but after sorting of these sub arrays. Fine. Now from 0 to 4 again recursively merge sort would be called from 0 to 4. 0 is less than 4, yes. Calculate mid. Mid is equal to 0 plus 4 divided by 2, that is 2. Midpoint is 2. Now again call this merge sort. Now see, ms 0 to 2, mid is 2. Now here again m is 3 to 4. Now here we have merge 0, then mid is 2, then 4, 0 to 2 and then 3 to 4. We are going to merge these two halves. Now next is, see this one, from 0 to 2. 0 is less than 2, yes, calculate mid. 0 plus 2, 2 divided by 2, that is 1, mid is 1. Again call merge sort. 0 to mid is 1, merge sort. 0 mid is 1, then mid plus 1, 2 to 2, only one element we have now. Now here we have merging of 0 to 1 and then 2. Fine. Now here again 0 and 1. 0 is less than 1, yes, calculate midpoint. Midpoint is what? 0 plus 1 divided by 2, that is 1 divided by 2, that is 0. 0 is midpoint. Fine. So here we call merge sort. 0 to middle element is 0 because 0 plus 1, that is 1. 1 divided by 2 is 0. And then again merge sort 1 to 1. And again we are going to call merge method on 0. Middle point is, lower bound is 0, mid is also 0 and upper bound is 1. From 0, 0 to 1 to 1. Fine. Here we have 2, 2, that is one element is there only. So we are not going to divide this anymore because lower bound is 2, upper bound is also 2. 2 is less than 2. No, this condition is not true. So we are not going to divide this. This is merge. Now come to this point. 3 is lower bound, upper bound. 3 is less than 4. Yes. Then we are going to divide this into 3 parts. See. 3 is less than 4. Yes. Find out midpoint. 3 plus 4, that is 7. 7 divided by 2 is 3 only. Fine. So here we are going to call merge sort. Lower bound is 3. Mid is also 3. Second is merge sort 4 to 4. And this one is merge 3, 3 and 4. Fine. 3, 3. Lower bound is 3, upper bound is 3. 3 is less than 3. No. 4 is less than 4. No. We are not going to divide this. Merge this. Then again we have this merge. Then finally this one. Merge sort 5 to 8. 5 is less than 8. Lower bound is less than 8. Yes. We are going to divide this one. Now see. Calculate midpoint. 8 plus 5, that is 13. 13 divided by 2, that is 6 we have. So middle point is 6. Merge sort 5 to 6. Then merge sort 7 to 8. And then we are having merge 5, 6 and 8. Then again come to recursive equal to this one. 5 to 6. 5 is less than 6. Yes. Again divide this one into 3 parts. Calculate midpoint. 6 plus 5 is 11. 11 by divided by 2 is 5. So merge sort 5 to 5. Then merge sort 6 to upper bound is 6. Then we are going to call merge 5, then 5 and then 6. Fine. Lower bound is 5, mid is also 5 and upper bound is 6. Now 7, 8. 7 is less than this 8. Yes, this condition is true. So again divide this into 3 parts. Now I am going to divide it here only. So now first is merge sort 7 plus 8. Calculate midpoint. 7 plus 8 is 15 divided by 2 is 7. So 7 is midpoint. 7 to 7. Then merge sort mid plus 1, 8 to 8, and then we are going to merge 7, 7 and 8, and finally merge 5, 6, 8, and finally merge 0, 4 and 8. So this is the recursive tree. Now how this is going to be called? See, first of all, merging of 0 to 8. Here we have first call would be to this function 0 to 4. We are going to first of all call the merge sort on 0 to 4. Again for sorting of this one, we are supposed to call this one. Now again we are going to call this one 0 to 2. For sorting off from 0 to 2, we are going to divide this again. So here we go from 0 to 1 only. Now for sorting of zeroth and one element, we are going to divide this into two halves only. So here we are going to call this one ms00 and ms1 and 1. 00 means we are having only one element now, 00, that is 15. Here we have 15 and here we have only 5 because we cannot further divide it. Fine. So this one is done, this one is done. Now next step is, now control would go to this merge. Now merging of 0 to 0, 0 to 0 is 15 and 0, or you can say 0 to 0, then 1 to 1, 1 to 1 is 5. Then you are going to merge this 15 and 5. Now how this merging is to be done? See, two sublists are there which are already sorted. You are going to merge those sublists and you are going to produce a new sublist, and that new sublist is also in sorted order. Fine. So after merging of this 15 and 5, the new sublist would be 5 and 15, right? How we are going to merge, I am going to explain that procedure also. But for now you have to keep in mind that two sorted sublists are there. You are going to merge those sorted sublists, so the new produced sublist would be in sorted order. So this would be 5 and 15. So after merging, the list would be 5 and 15. 5 and 15. Done. Now the control would go to here only. ms 2 and 2. 2 and 2. So this is only one element is there. 2 and 2, that is 24. Fine. Now this one is done. Now 24 is there. 24 is there. Now control will go to here only. Merge of 0 to 1. 0 to 1, this list, and this list is what? 5 and 15. And from 2 to 2, 2 to 2 is 24. So now we are going to merge this and this. That is why I am saying you cannot merge this 15 with 8 or 15 with 24. Or it's not like that this 5 and 15 is one list and you are going to merge this with 8. No. You are going to merge these lists with its adjacent list only. And when you are going to draw this recursive tree, then you come to know that how you are going to merge these sublists and how you are going to divide these sublists. Fine. Now this sublist would be merged this and this. Now this list would be 5, 15 and 24. 5, 15 and 24 now. Fine. Now control would go to here only. Now this one is done, 0 to 2. Now list 0 to 2 is what? 5, 15 and 24. The merging has been done. Now control would go to here only. Merge sort 3 to 4. Now again recursive call. So control would go to 3 to 3. One element is there. 3, 3, that is 8. We are having 8. Now control would go to here 4 and 4. One element is there, that is 1 only. Now control would go to this merge. We are going to merge 3 to 3. 3 to 3 matlab 8, and then 4 to 4, that is 1. So we are going to merge these two and the result would be 1 and 8. Fine. So here we got what? 1 and 8 after merging. I am going to discuss this merging method also. Now control would go to here only. Now this one is done. Now control would go to this merge. Now we are going to merge from 0 to 2, 0 to 2 this one, and 0 to 2 the list is this one. We have got this list. Fine. And from 3 to 4, 3 to 4 the list is 1 and 8. Now we are going to merge this 5, 15, 24 with 1 and 8. Fine. And after merging of this two, now the list would be this 1, 5, 8, 15 and 24. At this step you are going to find out this result, because when you are merging two sorted sublists, then result would also be a sorted list. Fine. Now this one is done. Now again we have done from 0 to 4. Now control would go to from 5 to 8. Now again this same procedure would be there. The control would go, recursive call is there, so from 5 to 6, then from 5 to 5, then here 6 to 6, then merging would be done, then again back to 7 to 8, then this one, this one, this one, and then finally merging of these list. Fine. So here merging of these two, then merging of these two, then finally this and this merging of these two. Fine. And ultimately you will get one complete sorted list. Fine. Now I am going to discuss with you how this merge function is going to be executed. Now check, we are going to merge first of all these two, and how merging would be done. Two sublists are there. We are going to compare the first element of these sublists, 15 and 5. Which one is less? 5 is less. So we are going to put 5 first of all. Then we will put what? 15. So this is the new produced sublist, sorted sublist. Fine. Now this would be merged with this 24. This 24. Now the new sublist would be 5, 15. In one sublist we have 5 and 15, in one we have 24. Now compare 5 with 24. Which one is less? 5. So we will put 5 here. Then 15 with 24. 15 is less. Then we are going to put 24. This is the new sublist now. Now 8 with this 1, and the new sublist would be 1 and 8. Now this with this 1 and 8. So finally the new sorted sublist would be, see, compare 5 with this 1. Which one is less? 1. 1. Then here we have 8, here we have 5. 5 with this 8. 5. Then 8, then 15, then we have 24. Fine. Same here we have 3 and 16. Here after merging we will get 10 and 20. After merging of these two, what you will get? 3, 10, 16 and then 20. Now we have two halves. One is this one and one is this one. Now finally you are going to merge these two, and ultimately you will get what? One list that would be sorted. Fine. And then we will stop what? Merging. Fine. Now see. Now this sublist is there and this sublist is there. Now how merging is to be done? Let us see. So now we are having two pointers. One is, suppose I pointer, that would be pointed to this lower bound. One is this J pointer, and two sublists are there. One is this and one is this one. Maybe you can say this is left and this is right sublist. Another list is there. We are going to produce another sublist, sorted sublist. Fine. Another pointer is there, that is K, which is at the starting of this sublist. Fine. And how many elements would be there in this sublist? Total of this and this one. Let us suppose here we are having m element, here we are having n elements. So total would be what? M plus n elements. Fine. So this merging function, the time complexity for this merging function would be what? Theta m plus n. M is number of elements in one sorted sublist, n is number of elements in another sorted sublist. When you are going to add these elements into this one, then how many elements would be there in this sublist? M plus n. So time complexity for this merge function would be theta m plus n. Fine. Now how merging is to be done? First step is, we are going to compare now first element of this with this, or you can say, suppose name is L, this name is R. So now we are going to compare L of I with R of J, and which element which is less, we are going to put that element into this sublist. Fine. So 1 and 3, which one is less? 1. So we are going to put 1 here. Next step is, we are going to increment this K. Now K is at this place, and we have placed 1 here. So now we are going to increment this I also. Now I is at this place. Now again compare L of I with R of J. 5 and 3. Which one is less? 3. So we are going to put 3 here. Again we are increment this K, and we are increment now this J, because we have put this 3 here only. Fine. Now again compare L of I 5 with R of J, that is 10. 5 is less than 10, so we are going to put 5 here only. Increment K k is now at this place, and increment I now. Now again compare 8 with this 10. 8 is less than 10, so we are going to put 8 in this new sublist. Now increment this k. Now k is at this place, and increment also I. Fine. Now again compare 15 with this 10. Which one is less? 10. So we are going to put 10 in this sublist, and increment this j now. J is at this place, and increment this k now. K is here now. Again compare 15 with this 16. I is because here and j is here only. 15 is less than 16, so we are going to put 15 here. So now increment I and increment k. 24 and 16, which one is less? 16. So we are going to put 16 here. Now increment this j and increment this k. Fine. Now 24 and 20, which one is less? 20. So we are going to put 20 at this place. Now increment this k, and if you increment this j, now j is greater than this upper bound. Fine. It means this list is now exhausted. Means you have already put this element, all the element of this sublist into the new list, sorted sublist. Fine. So this is now done. Now what you have to do? Now one element of this sublist is remaining. Now you simply put this element into this sublist, 24. Fine. And we increment I, so increment is also now greater than this element, so this one is also done. Now if suppose here 25 is also there, 30 is also there. Now what you will do? Now see, this list is done now. So you simply put all the remaining elements of this sublist into this one, 24, 25 and 30, like this. Fine. Here in this case we have only one element left over, so we simply put 24 here only. So this is now the sorted list. Fine. After merging of these sublists. So this is how the merging is to be done. Fine. So now if you write down the code for this merging technique, then how you will write? See, we are having a function merge, fine, array. We are going to pass lower bound, then we are going to pass mid, and then upper bound. Fine. Now next is, see, we are going to take I, j and k, 3 variables, and I is equal to from lower bound, and j would be from mid plus 1, because see here mid is what? 4, so j is from here 5, so j would be from mid plus 1, and k would be is equal to from lower bound only, from 0 only. Now next what you are going to check is, you are going to write down a loop while this I is less than equal to mid, this I is less than equal to mid, and plus this j value is less than equal to upper bound, j less than equal to upper bound. In that case only you are going to compare these elements, and you are going to put the element which is lesser into this new array. Fine. So now you compare. If a of I, see, name of this array is a of I is less than equal to a of j, fine, because the array is, this array name is a only. So a of I is less than equal to this a of j, then what you will put? You will put this a of I into this array. So we are going to take another array, that is name is b. So b of k, see, we have taken one variable k, so b of k is equal to a of I. Fine. And next what we have done? I plus plus and k plus plus, right? Else suppose this a of I is not less than a of j. this a of j is less than a of I, then what you will put? You will put this value into here only. So else what you will do, in b of k you will put a of j, not a of I, and then you will increment j plus plus and k plus plus. Fine. So see, in both the cases we have done what? K plus plus and k plus plus. So if you will not write here, then you simply write here k plus plus. You can, no need to write here only, you simply write out of this if and else, you simply write k plus plus, because in both the conditions you are going to do what? K plus plus, k plus 1 you can say. Fine. So this is to be, this procedure is going to repeat until we have I less than equal to mid and j less than equal to upper bound. Fine. Now next condition is what? Suppose we have reached j is greater than upper bound. Now we have already put all the elements of this sublist into this one, but still some elements of this sublist is remaining. Then what you will do? You simply put all these elements here only. So you have to check that condition also. Fine. You have to check that thing. If now I am going to take, suppose one condition is I am going to take this I has been reached to its, beyond to its limit. So suppose I is greater than mid, because I should be less than equal to mid. Now I has been reached to greater than mid, means I has been reached here only. It means all the elements of this sublist has been put here only. Now only some elements of this are remaining. Maybe some elements of this list are remaining. Fine. So if this condition is there, then what you will do? You will put now all the remaining leftover elements of this sublist to here only. So now what you will write? While j less than equal to upper bound. While j less than equal to upper bound only. Fine, because if j is also greater than upper bound, then no need to, then obviously there is no leftover element. So no need to put these elements here only. Fine. So you will write down that condition also, while j less than equal to upper bound. Fine. Then only you will put what? In b of k you will put a of j. And then you will do what? J of j plus plus and k plus plus. I am short of the space, that is why I am writing multiple statements in one line. Fine. And here you will enclose this while loop. Okay. Now second case is there. Here I has been reached to greater than this mid. Else, here if has been closed. Else, if j has reached to its upper bound limit, beyond to its upper bound limit, that is j is suppose now greater than upper bound. So now what you will do? Else you will check. Else maybe some elements, some leftover elements are there in this sublist. So you will check while I less than equal to mid. In that case you will do what? In b of k you will put a of I. You will copy all the values here only now. Fine. And you will do I plus plus and k plus plus. This is ending of this while loop and this is ending of this else loop. Fine. Now see, we have taken another array, that is b, and the original array is a. So now this b, suppose this is b. So now this is sorted array. You simply copy all these values to this a. Simply write down a for loop, for like this. For k is equal to lower bound, k less than equal to upper bound and k plus plus. And simply copy in a of k, you will copy what? B of k. All the values from b to a, and this is done now. And after that you will close this merge function. Okay. I know this is very congested because I have a shortage of the space, but I hope you got the concept of this merge function. And the time complexity for this merge sort is both in worst case and best case, it is order of n log n. So I'll make another video on this time complexity, how this time complexity is order of n log n, both in quicksort and merge sort. So this is all about merge sort algorithm. See, if you know the logic of this merge function, then simply you can easily write down the coding for this merge sort. This is the main funda, this is the main you can say the backbone of this merge sort algorithm. Fine. So this is all about merge sort. In next video I am going to discuss with you heap sort. So till then, bye bye, take care.